Alright, welcome to my video on properties of logarithms. Now I have a couple of different parts to this video series, so you're going to see this introduction is going to be the same for all of the logarithm problems, but I did want you to understand a couple of things. First is that logarithms are really nothing more than an alternative way to keep track of exponents. Now sometimes I refer to logarithms as like the land of the logs, okay, like a totally different universe or a totally different country. Okay, the rules, they're kind of similar, but they're also kind of different. Okay, so I want you to pay attention to those differences. For example, when you were dealing with exponents, right, and you were multiplying two terms, like if you were multiplying x times x, that gave you x squared. Now that was like saying x to the first times x to the first, and then taking 1 plus 1 and adding them to make 2, giving you x squared. So I want you to pay attention to logarithms in the same way because they have a lot in common with the rules for exponents. Okay, so just pay attention to that. Addition, kind of like multiplication, and subtraction, kind of like division, so look for those similarities. Now, the final thing I'm going to leave you with is there are some additional tricky rules, okay, that come with this because you're going to need to be fluent in converting between what they call logarithmic notation and exponential notation. So I want you to pay attention to those times where you're flipping between the two. And I want you to also pay attention to things like the bump rule, where you're actually converting between exponential and logarithmic notation, and also some of the other fun rules like the change of base rule and what's another one? There's one that also has like where the log of a number to that same base, like for example log of 10 to base 10, all right, paying attention to those kinds of situations and what they mean. So there's a lot of different properties that you're going to learn about, and I want you to just get what you get from each part and just keep practicing is my best advice, okay? Stop the video when you need to, go back and practice, and I'm very sure that you too will be able to navigate through the land of the logs. All right, here we go. All right, welcome to the land of logarithms, part 3, properties of logs. I'm going to show you some other properties here in a moment, and you may wonder why I call this the land of logs. I call it the land of logs because it's kind of like an alternate universe or a different country. It's like the rules are different, right? In England, they drive on the other side of the road, and we're driving on the right side, and they're driving on the left side. So when you're in a different country or a different land, there are different rules that you have to live by. So I call this the land of logarithms, and I refer to this sometimes in that way because the rules are kind of wacky and different. All right, well, the directions here for these first two problems say simplify or expand the expression, right? This very first one, I want to simplify. I want to show you a very short but important move that's legitimate in logarithms. When you have log of a squared, you can take the 2, that is the squared part, and put it in front. So this would become 2 times the log of a. Now remember, whenever you don't see a base here, what is the base that is implied? That's right, it's base 10. So another way to rewrite this would just be 2 log to the base 10 of a. Okay, you don't have to put that 10 there if you don't want to. All right, it's just a way to kind of make clear on a couple of things. All right, now this next problem, I'm going to expand it as well, but it's going to combine some of what I did before and include a couple of new steps, okay? So the first thing I'm going to do is I'm going to look at how this is set up. I've got x cubed times y, and it's divided by z to the 4th. So what I can do and rewrite this in an expanded way is I could say log of x cubed plus log of y. Now the reason why I wrote the plus there is because when we expand our logarithms, the multiplication changes to the addition of two separate logs, okay? And then I'm going to put a minus sign here because we're going to subtract log of z to the fourth power, right? And I put a line through my z's just to make sure that they look different from my 2's, okay? It's kind of a European thing. All right, now, just like I did in the very first example, I'm going to put the exponent, the 3, in the front. So I'm going to write 3 log x. Now, y just came with a single 1, right? It's understood that there's an exponent of 1, so I don't really need to do anything over here. And then the 4 I'm going to put in front over here. So 4 log of z. All right, so this is my answer in expanded form for these first two problems, okay? Now, in this particular problem, since it says 3 log 15 plus 2 log b, this is going to be an example where I simplify, all right? So I'm now going to do the opposite of what I did before. So the first step is going to be to bring the 3 up here as an exponent and bring the 2 up here as an exponent. So this becomes log of 15 squared plus log of b, whoops, this was a 3, my bad. Sorry about that, 3, gotta make that a 3. The squared goes over here with the b, okay? So the 2 moves up here, and that's where we're at. All right, now one last move. I'm going to get rid of the plus and use multiplication. So I have log of 15 to the third power times b squared. Now if I want to be super neat, what I can do is I can figure out what 15 raised to the third power is. And if I really wanted to be super slick, I could do that. Sometimes they're not going to write this in your textbooks. I don't know why, but maybe they're trying to save some space as well. All right, so that is taking something that was in an expanded form and simplifying it. Now there's some other properties that you see down here, and I'm going to run through these really quickly, but basically these are properties that I want you to memorize. When the bases are the same, then the value of this is equal to 1. All right, no matter what the value is. If this was like log of 5 to the base 5, that would also be equal to 1. Okay, it's the same thing. So keep that in mind. Whenever you take the log of 1, the value is 0. Again, no matter what the base is, if you take the log of 1, that's equal to 0. All right, pretty important move. Now the log of 0 is kind of annoying, all right? Because of the way that the graph goes for logarithms, it is actually undefined. And you actually may get an error on your calculator. For example, if I were to take the log of 0, put that in my calculator, here you can see that the calculator hates me right now. See, it says error in the domain. I put a number in I wasn't supposed to. All right, so let's just pretend that didn't happen, okay? So here the log of 0 is undefined. We don't know where that is. All right, now here's a fun trick, all right, that deals with logarithms. And again, think of these like tools in your toolbox. This is a situation where you have the log of some term, and that term and the base happen to be the same thing, right? So just like before, we put that 4 in front in the previous examples up there. Here we have 4 log of y to the base y. Now what did I say just a couple of moments ago? When the number and the base are the same, the logarithm is equal to 1. So these are the same. The logarithm is equal to 1. And so we can simplify this all the way to 4. All right, so this ugly mess that started here actually simplifies to 4. All right, now this one is really the last of the Mohicans. All right, this is kind of a tricky thing. So what I want you to do when you run into a problem like this is to first panic. All right, get your panic on. All right, now that you got your panic over with, here's what you're going to do. Remember that when the logarithm is not written, this is the same thing as 10 log to the base 10 of 2. All right? And it happens that 10 and logs to the base 10, these guys are opposites to one another. They actually cancel. So when you see 10 to the log 2, these guys cancel each other and your answer is just 2. All right? That seems a little weird, but log of x and 10 to the x are opposites. All right? Now I can prove that on my calculator. If you take a look and you hit second function log, you'll see you get a special 10 raised to some power. Now if I were to type in log of 2 in parentheses, all right, and I'm going to use double parentheses there, right, because I have 2 sets. You see how you get 2 as your answer? So that's further proof for you that what I did was a legitimate move. So when you have 10 raised to some log that is log base 10, the answer is simply 2. All right, now when do you use these tricks? Well, I can't really tell you because that requires you to practice an awful lot of math problems, and you need to become familiar by practice. There's no way that simply by looking at all of these things that I've shown you that you're going to instantly know when and where to use these tricks. So my advice to you is take it slow, look at these different tricks and experiment and see which ones work for a particular problem, and with some practice I know you're going to get the hang of it. Okay, enough of me blabbing. I'm done with part 3, so are you. Look for more videos if you need more practice, and I'll see you next time. Okay, you just got done watching a video on the properties of logarithms, so hopefully your logarithm kung fu is a little bit stronger than it was before. And all I can emphasize at the end of these videos is practice. Practice, practice until you know it in a way that you don't even have to think about it, okay? A lot of these rules are not natural, okay? Things like the change of base rule and the bump rule and, you know, even simple operations that you'd think, oh, okay, I'm just going to add these logs together, and then it turns out, hey, why am I multiplying these things, right? So there's a lot of rules that are kind of like a little different with logarithms, and you really do need to practice them in order to get better. So be sure that you get really good at converting between logarithmic notation and exponential notation. Make sure that you're becoming familiar with all those special rules, right? The bump rule and those kinds of things. And then finally, just keep practicing, okay? You're not going to get better overnight. Just give yourself some slack, right? Give yourself some patience. Be patient with yourself, and then just practice. And I'm sure you're going to be good at this in no time. All right. Good luck. And if you need more help, watch another video.